in celebration of World Space Week 2020. Thank you for attending and being very consistently excited throughout this week. And today we have a very special guest with us. In addition to her constant support throughout this week, she will be giving us a very exciting talk. We have Dr. Cyrine Nehme, PhD in Physics of the Universe, Astrophysics from Observatoire de Paris Meudon, and the director of World Space Week in Lebanon, with a talk about exoplanets and the world's new hunt. After her talk, we'll have a 10-minute intermission and we'll take your questions. Then we'll be with our Moment team members, Mohammed Kanan and Mariam Osman, who will be introducing us to the International Space Station and giving us an insight to the kind of work and the life that happens over there. So thank you all for coming, and we hope you enjoy it. And take it away, Dr. Cyrine.
Thank you so much. I hope it will be exciting. I think that the ISS will be more exciting than talking and just looking at slides. Actually, hunting new worlds was like alien. If you want إنه أحكي عربي from time to time, please interrupt me. ما عندي مشكل, or French. The term were alien for people like 30, 40 years ago. يعني you would never thought like كنا رح نقول hot Jupiter or مثلا super Earth, mini Neptunes, circumbinary planets, seriously, pulsar planets. And what was like كانوا قبل يفكروا إنه our solar system and our sun is the center of the universe and the exceptional thing. It appeared like إنه it's not even challenging to be on our solar system. And one of the best thing is to know this is, if you're lucky to go in a dark sky rarely those days in Lebanon and in some places on Earth, you look at the sky and you see some powder like this and dark and spots in the sky, and then you wonder what's happening. And this is what's everything's happening. هو فوق. This is the center of the galaxy, or the galaxy, our galaxy, and there's where the stars are forming, are dying, and we understand what's happening there. So from this beautiful nature, this beautiful image that we are looking on Earth, we will understand several things, and let us continue. I personally thought that the best thing that I ever saw in my life was this beautiful image when I was a child, and I always was excited by the universe and the cosmos, is this planet Saturn and the rings. And I always wondered why we don't have rings and what's going on, why there is rings, ومنو هيدا وشو هيدا الشيء. And understanding the rings of such a planet is somehow, and afterwards it appeared that we can understand several things and the formation of the solar system and other solar systems by understanding rings. So it ended up that the rings are not that banal, منن هيك بس بايخين. And when preparing the talk, لاحظت إنه I'm not the only one who was passionate by Saturn, and Saturn is the love of several astrophysicists and astronomes amateurs بيحبوا الفضاء. And I think that you know why. It's beautiful, and I keep a surprise for you in the talk. So in my humble opinion, I think that one of the biggest development and research in astrophysics and astronomy, in physics of the universe in general, is the understanding of the cycle of the stars, the life and death of the stars. Because once we understood the formation of the collapse of a star, and from the molecular cloud, the giant clouds in the interstellar medium, for example, for a sun like our star, it will have بتعيش مبسوطة وبتعيش حياتها. And then on the left of the slide, we will have the red giant and then planetary nebula. It will end up by white dwarf with the shock, will cycle, will form another star. And for the big 10, 20, 30, more than our sun, we will have like those blue stars that you see in the sky. We will have red giant, super red giant, and supernova explosions, neutron stars, black holes. But what will be left, they will have metals, very rich, that will enrich our universe, so our galaxy, with heavy metals. So understanding this processes of stars, and here I think my colleague Marwan Jabran would be so happy, because he always considered the ISM, the interstellar medium, is just like, you know, not good for the signature for to observe the stars. And I always told him that the stars are really bad for our study in the ISM. But really understanding the life cycle of the stars is really very important, because we understood, one, that we are not that special. We have a lot of stars in the universe. Second, we understood that with the cycle of the stars, the life and death of the star, we are enriching our galaxy with metals. By the massive stars, the explosion, they will live أصغر, they will live like, they will be shorter, they will have shorter life, and they will give us what we call the metals. And then the metals, formation of planets, formation of life. So those parts in the science and astrophysics are very important. And every one of you have seen this periodic table, and I know and I trust you that all of you know it by heart, this hydrogen, helium, lithium, beryllium, bor, carbon, azote. Okay, so we as astrophysicists, we consider the hydrogen and helium are the gaseous part, and everything that beyond the first line, the hydrogen and helium, is, we tell it that it is solid, it's metal. Okay, and you see that there's separation between in colors. We have the beige, it's like from the Big Bang. The blue violet one, purple, it's from stars. The orange yellowish one from supernovae. And you see that a lot of heavy metals come from supernovae and from stars, from the life of carbon, nitrogen, oxygen, fluor, neon, magnesium, calcium, iron. So if stars and supernovae didn't form and exploded, there's no life. We will see later on why. So, and just between brackets, for those who know and looked at Breaking Bad, so this is the BA and this is the BR, it's somewhere here. So BR and BA are from supernovae. So understanding those phenomena of formation of stars is really very important. And this is what gave us the idea that we are not exceptional. With the development of telescopes and wide field observation, we have this great image of nebula of Orion. And I think that several of you have observed it, have looked at it, have painted or wish to observe it. And this is where several formation and death of stars happens. We started to observe this, and if we zoom in it, you see here we have several boxes inside, and you see some metal circles or some traces, dark plot. And if you zoom in it, if you go to zoom in it, you see we have several like mosaic of kind with shock waves, dark spots, bright spots. So what are those? Those are فينا نسميهم des prolide or protoplanetary disks that they were discovered in the 90s and late 80s, confirmed in the 2000s. and we have more than 42 here and more than hundreds in the Orion, Great Orion Nebula. So those are happening now. What are we now when I mean, well, خلينا نكون متفقين. So when I mean now, if they are like 10 million light year away, I mean, we are observing it now, this image, but the light أخذ 10 ملايين سنة ضوئية أو مليارين سنة ضوئية or whatever. But what I mean is that we received them 10 years ago, the light 20 years ago. So we are seeing them. Of course, if I take a plane and I go to see if the state is information, أكيد لا, لأنه it is تغيروا. But having said this, we are observing it information. So at the beginning, we didn't understood. And because we are معودين to see the circular shape of a nebula, like they named the planetary nebula as a planetary nebula, وهي ما خاصة بالplanets, it's just because it's circular, spherical, when it will blow out blow away the materia. Here we started to understood, and it was somehow asymmetric, symmetric, and then with the observation we started to understood until we wanted to understand what are really those. So here, why it is hard to discover the exoplanets, why it is difficult to characterize, and how we can detect it. It's not just important to observe. So we have to characterize. شو يعني characterize؟ يعني أنا if I want to observe something بدي أعرف what is that. طيارة, صاروخ, planet, شجرة, fromage. And what are we observing? A Jovian planet, gases, a moon, small, carbon, nuclear, it can kill us far away. So we started to observe something in 1984 with IRAS, and we saw some kind of jets. They were observing it. When I say we, it's not me. I was not born in 94. And I mean astrophysicists. They observed toward target. It is Beta Pictoris, and ما كانت هالقد exciting, but you will see that Beta Pictoris is very exciting after and after. So they saw an excess in the infrared. As a normal star, I think it was a G5, no, I forgot, but the type of the Beta Pictoris was not that ما كان لازم تعطي هالقد excess in the infrared, thermal infrared. And then they observe it another time, and they study it, and they saw that there is something extending around it. They restudy it, they reobserve it in the 90s, I think, or the 89, and they decided after to do a coronography. What is the coronography? For example, هلا أنا مضوية كتير أضوية for you to see me very well. So if I do this, you see the light, I'm blocking the light to be able to do some fake contrast. Like this, I can see what is not blocked by the heavy light. So this is what they did, the coronography, and they observed that we have something emitting in excess that is dust. What is emitting in the far infrared, it is dust, and it is kind of blown out from the star that is blocked out with the coronography in the instrument that we observed with. So this dust that is emitting will suggest that the sizes are somehow plus ou moins big, that we can have some kind of comet, asteroid, or some planetesimal. So this is how we can. So the suggestion of presence of extraterrestrial planets in 1984. So now how we are going to observe those exoplanets? Since the beginning من 28 years صار في أكثر من 12 methods, and trust me, we are going to observe, discover, and create several methods. But because we don't have time, I will be really pleased to talk about it for 6 hours, but I really needed to make it really short and clear. We can observe with a direct method, direct imaging. So here we have the, okay. So here we have the, you see up on the left, the star. I will block the star with the, with something like coronagraphy or another method. We can do it with the optics. And like this, I will be able to artificially increase the light of the planet that is near to it. Why? Because the planet will not emit itself, it will reflect the light of the star. And taking a picture with your phone, like you take a selfie or like you take a picture of Jupiter, is not possible for exoplanets. We have a lot of problem with that, because the distance between us and the extraterrestrial planets is so big, and the separation ما في كتير اسباس، ما في كتير سبيس بين البلانت وبين الستار لحتى إذا نحن صورنا نقدر نفرق. And also because the star بتضوي كتير, so it will saturate, we cannot see the tiny reflection of the planet. So one of the ways to take a direct image is to block, and we can see. يعني انتوا اذا حدا بتكونوا مثلا نايمين عم تقروا بالاوضه، بفوت لعندكم حدا بتكونوا عم بضوي لكم الضوء، شو بتعملوا هيك to see. It's exactly the same thing. So this is, we do it instrumentally or with several methods with the optics. The second method is the astrometry. We discovered a lot with the astrometry. So the astrometry is the effect of the presence of a companion for a star on the system star-planet barycenter. When you have two bodies rotating around each other, even if you have a big one and a small one, because of the influence of each other, their center of rotation, the mutual center of rotation, will rotate itself around a barycenter. And with the precision that we have nowadays, with the instrument developed, we can measure the small change of the center of rotation. يعني ما بقى بتبرم الستار حوالين حالها، بتصير تبرم حوالين حالها بس بزيح راسها هيك، يعني بيعمل like wobbling. And believe it or not, Jupiter, our biggest planet in the solar system, influence of the rotation around the sun, around itself, وبيعمل لها wobbling. So it will تبرم شوي على حالها. So we have what it is commonly used and overused, and it is successful, and we are going to use it, which is the radial velocity. The radial velocity is kind of Doppler, but it's a spectroscopy Doppler. When you have a star and a companion, a planet, and we are observing it with the spectroscopy. So if you are receiving the light of the star, when the planet is near the star, it will influence the message, the light that, I will repeat it, it will influence on the message, يعني the light that will be sent, that you will detect. Look at this. When the star is going away, so it's influenced, the light that will be received, it will be so it will be away, it's red shifted. When it's going toward us, it will be blue shifted. ليه؟ لأنه على طول imagine as if we have this حبلة تسحب لي and the wavelength لما تبعدوا بتكبر لما تقربوا بتصغر. So this is normally if a star is alone ما لازم يتأثر، لازم always to have the same wavelengths. When we have different wavelengths عم تتغير يعني we are having a companion. This is something also عندها disadvantage. The radial velocity disadvantage تبعها إنه it needs big Jupiter-like to measure this change. Imagine that Jupiter-like planets, for example, you can measure the signal for change in 12 years, like 12 meter per second. If it is an Earth companion, 10 centimeter per second. So, but we can do it because we are developing sensitivity, resolution, very high instrument. And the radial velocity method can give us information to characterize the mass of the exoplanets. Now, the very well known and used and abused with Kepler is the transit method. So what is the transit method? And everyone, I think, knows it, is when a planet is in front of a star, exoplanet is in front of a star, and it will pass in front of it. What do we have here? We have that the light of a star is dimmed, and it will pass, then it will leave the star, the field of the star, تطلع ترجع البرايتنس بالكيرف لايت. شو صار عندنا نحن؟ عندنا time of passage لعندنا the dimming of the curve light. بس here كمان we have a disadvantage. عندنا disadvantage إنه لازم نكون somehow in the line of sight, because إذا كنا هيك we cannot have a transit. And this will give us an idea, this method will give us an idea on the radius on the planet, exoplanet. So always when we do observation of exoplanets, we do follow up. If we observe with transit, we have to observe with radial velocity and vice versa. I think that you got the idea why, because if we have mass, we can calculate the radius, then we can have the density. So the volume means that we know if it is a terrestrial or a Jovian. So what if we have two planets? So we have this passage, the first one, you see the first dimming, and the second one and the third one. So the second one will show me that it is smaller, and the third one, for example, it is smaller, smallest. So from the transit also, we can see the sizes of the planet. We can also know if we have different exoplanets from the radial velocity also. I didn't mention that. And another method that it is used, which is the microlensing. I think that Dr. Sabra or Dr. Marzoub yesterday or 2 days, they were talking about the Einstein and the space-time. So this is something also Einstein, when he talked about it, he said that it's not possible, it's really impossible, because we will never have this case. And I will explain to you, but it was possible, and we are using it and we are observing it. We are observing exoplanet with this method. What is the microlensing? Actually, we know that gravity will bend the space and time, the sheet that Dr. Sabra was talking about of the space and time. So if we have a detector that is in the telescope in the down of the page, and we have a very, very, very far star, this star that is very, very far, it's sending us the light. If it happens that we have a planet or something heavy passing in front in a line, straight line in front of, between the detector and the star, the light from the star, far star, will not be in a straight line. we will have like the planet in between will play like a lens. The light will be bending, so we will have a magnification. The light will not be exactly the same. It will be virtual magnified like a loop. So if there is a companion with this star, لمرأة بالنص, this companion, the light of this companion will be also magnified. But Einstein said, what are the odds انه نكون حاطين التلسكوب ونطلع على نجمة ويمرق نجمة بالنص مع planet and we observe it. And yes, we are observing. So this is another method. All those, we are talking about them on the World Space Week. And for those who are here, don't forget to continue, because tomorrow we have also 2 talks, I think, and on Saturday we have the competition. Okay, let us continue. And the discoveries, the real discovery were for the pulsar, and that was in 92. And هون صارت الصدمة. Why صارت الصدمة? Because they never thought that they will discover an extraterrestrial planet around a pulsar. And you see, I really laughed because they called it a zombie world. A pulsar is very energetic and you know, it's so, but until 1995. And why everyone will remember this moment, this day, this event? Because it is like the first extraterrestrial planets around a star like ours. We will not talk about a pulsar. And this was the first exoplanet, and yet nobody thought that it will be a hot Jupiter with a period of 4 days and a half, and what, hot Jupiter? And then the discoveries continued, and we are not stopping now. And here I will talk about interesting cases like the circumbinary planets, Kepler 16. Well, circumbinary planets, I don't know if some of you are fan of Skywalker, because it was mentioned in Star Wars, and the name of that was Tatooine. So it's a system with 2 stars and a planet, with 2 sun and a planet. And that was also unprecedented. After that, can you think that we are exceptional? And I just take 2 seconds. So imagine that you have 2 stars, and that was in 100, I think, also, or something like that. Anyway, so I'm sorry that I will skip a lot of history and a lot of things, because lately, I mean, Kepler and other telescopes discovered a lot. And we are going to I'm going just to talk about the very interesting for life, for terrestrial. And اللي بياخدوا هيك البرايسز التابلو دونور هن الhabitable small or habitable zone of not just exceptional and very interesting, but different kind of interest. And those are not the only one. If you see that we have like our solar system, multiple extra solar system around different type of stars and in the habitable zone. And if you see here, it's not that around J star بس في اثنين. Around J stars, those are detected by Kepler around J star because they need a different time and period to observe, and Kepler had observed in a one place and كان عنده periodicity محددة. So this is an observational bias, if I may say. But مش يعني إنه around J star بس لقينا one planet like in the habitability zone, okay? So, and the other also هلا I will explain to you a little bit what is the habitability zone. And also we have TRAPPIST, like 2 or 3 years ago. We discovered more than six to seven exoplanets in the habitability zone. And we have to know that the habitability zone, la zone habitable, is under evolution. Because first, when we thought about an exoplanet that in a zone that is habitable, maybe we thought that maybe habitable to have life with a smart ET. Like also we thought about, you know, the factor n Drake life. Also, n, the number n of Drake's formula is changing, because now we are thinking in terms of habitability, in terms of finding signature of life. So we have this updated habitability zone, habitable zone in the habitability, to be habitable. So we have the optimistic one اللي هي كتير كبيرة, and the conservative one. So in terms of, on the left, the type of stars, and on the right بنشوف اللي هن ال percentage of finding planets. If we take the optimistic one, نطلع ب a star like ours اللي هي تقريبا on the temperature 6000, هي surface temperature الصفراء دغري تحت الكبيرة من فوق. We have كأنه فينوس، إذا بنطلع بالسولار سيستم تبعنا كأنه فينوس بيقرب. What we see, what is really interesting, because now we are so excited about Mars and we found water under the surface of Mars, water. So Mars is in the conservative habitable zone. So if we take this, in the conservative and optimistic. So if we take this optimistic habitable zone with the several stars type, we see that we have a lot of extrasolar system that they can be habitable. And you see that we have Proxima Centauri b, we have Gliese, we have TRAPPIST, and a lot. And now, like 1 hour ago, I was looking that there is super habitable Earth detected, super habitable. So one of the most exciting things that happened in the discovery of extraterrestrial planets, exoplanets, the Beast J1407b, هو أطول اسمه هيك, بس إنه they cut it and they said that it's really rebarbative كتير صعب. When they were observing in a transit method this exoplanet, the star, they saw that it was dimming several times the star. They didn't understood. A star doesn't disappear several times, and like at one time it just disappeared. A star doesn't die like this. They did a model, and you see here the light curve on the first slide on the left, the second. They did a modelization, and it appears that it is kind of a ring. They don't know if it is, they call it the Beast. They don't know if it is a dwarf star, a planet. The rings are 200 times bigger than that of Saturn's. And they said that, imagine that if you are on Earth and you have a planet on your solar system, that it is like this. So this was from the newest and very beautiful discoveries that we have. Now, to do a small resume for what Kepler, I choose Kepler because the transit method is what we will be most used, and what the big data that we're studying are from Kepler, and several discoveries are from Kepler. But I could have chosen other, but I have to choose one because we don't have time. So you see that we have a lot of sizes in the data, and it's not just studying the planets, it's also to study if they are small, gases, how big, because when you study with transit, you can study also the atmosphere to characterize it. When you have a transit, You can study the spectroscopy and the light that is passing in the transit. You can study the composition of the atmosphere of the planet. And here you can have some kind of an histogram to see how many of your confirmed are Earths, super Earth, mini Neptune, large Neptune, and gas giant. You see that after taking out the bias, you can, I don't know if you are familiar with those histograms from red, green, blue, but this is a histogram without any bias of observation. You see that there is a lot of fraction of Earth size and super Earth size. So what we are seeing here is the relative size and orbits of everything that was discovered until 2014 or 13. I didn't found a new one for all the Kepler extrasolar system. So those are like our solar system found by Kepler. And what is interesting is that you can find a big star with small with the rotation, their orbit. Okay, I will stop here because I need you to What's next? What's next? I need to put, I think it's Shift F5. Yes. So what's next? We have TAS, we have a lot of telescopes, even HST, who was not programmed for observing exoplanets, is now also observing exoplanets like for 10 years. So the next is study Kepler's data, because there's a lot of data, and James Webb Space Telescope. So yes, it's going to be launched, and it's not dead. And it is, you see the difference between the Hubble mirror and the James Webb mirror. So it's done. Those are new images of the James Webb. So just a small comparison between a Boeing and the HST size. The Webb is like a little bit close to the Boeing size. It will be on the L2 to have less and less pollution. Independent, and to be like L fuel and energy consumption. And the hot, it was published yesterday. The NASA Webb was completed the environmental testing. He survived harsh conditions, and when they do this, means that the next step are the condition of the launch of the space. So as you see that the mirrors are ready to be put in the Ariane space in La Guyane. So the mirrors are, you see the difference here, the mirrors are open, like the big mirror, like a niche of Al-Abay, but everything is ready now to be put in Ariane in normally 6 months, finger crossed. So the key facts for James Webb, it is 100 more better than HST. It will be ready to observe the atmosphere of exoplanets and detect more and more water. It will be observing the origin of the universe, and several stuff. Why I'm smiling, because the 2 months ago we had postponed to 6 months. So I'm not daring to say that yes, it will leaving, but anything can happen. So it's sensitive to the far infrared and the infrared. It has several detectors, and it's going to do the difference, to make the difference, especially that it's in the space. So we will see what will happen, and the detection of that. And I think that, as I told you yesterday, this is the last, and this is, I'm sure, this is the last big telescope that it is going to be sent to the space with that cost. So to finish, maybe finish, I just wanted to say that I never thought one day I will be, I always dreamt of, I worked on it, but I never thought that one day I will be talking about this. On the left, I'm the little girl in the mountain with Dar al-Qamar playing piano. And on the right, I prepared the Miri. This is me, by the way, the mid-infrared that is now on the James Webb, that will leave the space. It's kind of my baby, that it will go to the space. And then up is the white room, where you saw now the mirror. And this is my pass to NASA Goddard in 2016 when I worked in NASA. I went there, and from there to NASA, I just wanted to tell you nothing is impossible. And this is me when I had my hair curly. So what is next? Next is to search for life. When we say life, we don't think about Martian or هول الخضر. We just say schnapps or sponge. Carbon, hydrogen, nitrogen, oxygen, phosphor and sulfur. Phosphorus or sulfur. Or sponge, because I'm French, so French بيقولوا sponge. Because for the moment we search for life as we know it, like this. It's a carbon chain. And we are searching for everything that has water, and where it is أول شيء habitable to maintain water, the pressure, the temperature, the insulation, where the bacteria can live, any bacteria, any cell made of those 6 elements. And for this, I'm pretty sure we are not far from that. And most of all, I think that we are not alone. And شكرا جزيلا. I hope that ما زهقتكم, and I don't know what time it is. Thank you so much, and I'm waiting for your questions. Hello?
يعطيكم العافية.
ما سمعت، قطش يمكن الكونكشن.
يعطيكم العافية، عم تسمع؟
Yes.
يعطيك العافية دكتورة. سؤال بس عن الإكزوبلانتس إجمالاً.
نعم.
بس في شيء بالأول لازم نعرفه، يعني مثل ما بيقولوا we are stuck in two worlds. في الريلاتيفيتي اللي بتفرجينا إنه اليونيفرس هو deterministic، يعني we are able to predict its behaviors. وبس بذات الوقت في الكوانتم ثيوري والكايوس ثيوري لا برهنت إنه اليونيفرس probabilistic laws of universe. فالسؤال هو is there an organized pattern behind this system؟ يعني تحديدا بالنسبة للإكزوبلانتس والانتليجنت لايف اللي عليها. يعني نحن هلا على الكرة الأرضية صار عمرها 4600 مليون سنة، وكأنه 4100 مليون سنة راحوا هيك ولا شيء. آخر 500 مليون سنة لحتى بلشت تتطور الحياة. آخر 500 مليون سنة من organisms ل complex life structures، وكأنه هاي 4100 سنة يعني راحوا هيك مشي وبس آخر 500 مليون سنة. أو إذا في شيء دقيق ممكن نقول إنه هول 4100 مليون سنة كانوا prerequisite ومهدوا لآخر 500 مليون سنة. فينا نقول هيك؟ يعني في شيء organized pattern behind this system، ولا هلا نحن عم نحكي وفجأة مثلا يجي نيزك ويضرب الأرض وحضارة عمرها 5000 سنة تروح فجأة؟ هذا اللي حابب أعرف.
يعني بسؤالك في شي 10 أسئلة. رح بلش. it's very interesting. أنا كتير بحب الأسئلة after the talks لأنه على طول in astrophysics ما فيك تفصل مثل الماثيماتكس، ما فيك تفصل بين الفلسفي والساينس. رح بلش بآخر بارت من سؤالك لما قلت ولا في مثلا يجي هلا نيزك ويشبق فينا وتروح الحضارة. هيدي فيها تكون، فيها تجي probability كتير ضئيلة، صارت من 65 مليون سنة، بس فيها تصير، فيها تصير. هلا السؤال الثاني انه اذا ليش تاخر صار للارض 4 مليار ونص، ليش تاخر لصار في لانه اول شيء الارض it was formed in a big explosion. اوكي، مع الشمس لحتى هي ارتاحت وصارت تبرم وكذا، بعدين الارض شبقت فيها تيا، عملت القمر، والارض لحتى سقعت. you need to know what are the conditions to have life لبلشت الحياه. هلا هون انا ما بدي فوت بالدين، اوكي، بدي ضل بس شوي بالعلم. يعني you need time to settle البلانت، بعدين this planet you need time to put it in the habitability. يعني لتكون بالhabitable zone لازم يكون عندك طقس حلو فيها مي مثل ما بنعرفها الحياة، بعدين لتتكون البكتيريا. يعني عندك انت شي مليارين سنة لحتى يكون في possibility of life. هلا صار في possibility of life، بدك تشوف للأورجانيزم، يعني ليجي مش انه اذا عملنا سلفر كربون فوسفور اكسجين هيدروجين حطيناهم باللاب ونطرناهم من مليون سنه، مش يعني رح يصيروا لايف بكتيريا. So there is في من 2 years I think من 1 year and a half in May رحنا على ناس I have colleagues بفرنسا هن they are trying to form life. المشكلة بالفيزيكس in general نشتغل على الكونسرفيشن of energy. Life does not work like this. الحياة البكتيريا. So يعني there is something to trigger the إذا بدك في entropy يعني في ف this is it. You don't ما خص it's not a منه linear drawing, it's not a straight line، منه زيح خط انه هل 5000 سنه كذا ما منا it's not straight, it's not a direct، يعني منه effect ونتيجه وخلص اجت الشجره اجت الهيدا كبر فيها تكون اللي قلتها كمان، فيها تكون انه اول 500 مليون سنه 4000 كله ماشي، بس ما فيها تكون ماشي لانه لو ما مرقوا هودي ما صار في نحن. بس وين هلا الاخطر انه نحن هلا المشي،
بس
لانه نحن هلا بوان موليكول فينا نرجع على المشي.
interesting. thank you.
You got me. لا ليش عم بقول لك هيك، بدي بس خلص اذا بتسمح لي لاقول لك مش عم بتشائم ولا عم بحكي سياسه، لانه لما نفتش على مش الاكزوبلانت ولا الاكستريستريال لايف، if we search for intelligent outside people for ET في عنا theory بتقول انه population number 1, population number 2, population number 3, and why they are not contacting us because they started to be very developed that they kill their civilization. وهيدي مش انا قايلتها، كارل ساجن.
في هون بارادوكس يمكن بسمع فيهم فيرمي بارادوكس يمكن I think.
هلا غير شيء
intelligent. شكرا. ثانك يو.
يا اهلا وسهلا.
اوكي، هلا بناخذ سؤال من احمد سرحان.
يعطيك العافيه دكتوره. بدي اسالك بالراديال فيلوسيتي ليش الشمس بعدت ما قربت على جوبيتر؟
هيدي مش الشمس، هيدي انه another star. كيف يعني؟ هي عم تبرم هيك، هن عم بيبرموا مع بعضهم هيك، هي عم خليني ارجع اشرح، يمكن ما كنت واضحه بالراديال فيلوسيتي. الراديال فيلوسيتي هي اني ستار، كل شمس بتودي ضوء، اوكي؟ ونحن عم نلقط الضوء. هيدا الضوء لازم يكون ثابت. هي الشمس معروفه، مثلا تايبا 5B 5F BG وات ايفر، اوكي؟ سو بنلقط لها الضوء. اذا كان في حدا شيء عم بيبرم حواليها بده يصير يبطئها، عرفت كيف؟ بده يصير يعملها بده يأثر عليها. هي وعم تبرم هيك بدها تصير تغير محلها، بدها تصير هي وعم تبرم، يعني كيف عم تعمل وابلينج، بده يصير يتعبها لتبرم. هي وعم تبرم بدها تصير تغير الضوء تبعها، السبكتر، الاميشن. ليش؟ لانه بطلت عم تبرم بحريه، صارت عم تبرم هيك. لما يكون مقربة عليك تبعت لك اياهم زرق، لما يكون مبعد عليك تبعت لك اياهم حمر.
هيدي فهمها دكتورة، الريد شيفت والبلو شيفت. بس اللي قصدي عنه انه هي مثلا الشمس بتكون عم تبرم حوالي الاكس اللي لها، بس وقتها
بطل تبرم حوالين الاكس اللي لها. لما يكون في حدا بتصير تزيح عن اكسها هيك.
ما هيدا اللي قصدي عنه، انه وقتها يقرب جوبيتر عليها. ليش بتزيح الاكس بعيد عن جوبيتر مش قريبه لجوبيتر؟
لا هلا اذا فيل ونمله،
اوكي،
اذا فيل ونمله عم بيرقصوا مع بعضهم، وين بكون الباري سنتر؟ وين بكون مصدر الجاذبيه؟
عند الفيل.
ايه، مشان هيك بتضل هي تبرم حوالين حالها بس بتزيح نقزه.
كرمال ده السنتر دماس محله.
يا عين عليك، حد السنتر دو ماس بيكون vers le plus massif.
اوكي. في شغله ثانيه.
نعم.
مثلا كوكب الارض، من وين اجوا الاتومات الثقال عليه؟ لانه هو بالفورميشن اللي له يعني ما بيقدر يجيب مثلا الحديد وهيك.
هلا في عنا سوري، خلصت سؤالك ولا؟
ايه خلصت.
قطشتك يمكن، انا تحمست.
خلصت.
في عنا في عدة طرق لنعمل الكواكب الأرضية والكواكب الغازية. الكواكب الصخرية هي بالدست بيعملوا اجلوميراسيون. دست يعني هن الدست بيكون غبار الكوني. لما بجت الأرض سوري الشمس عملت هيك، عملت كولابس لغيمة، لأنه صارت تحت الجرافيتي. هيدي الغيمة الكونية الموليكولر كلاود، هيدي الهون شفتوها؟ اوكي، عملت كولابس، بجت عملت بروتوستار. هودي البجوا بيسقعوا، بيصيروا يعملوا دست. الدست بيتقلوا بيعملوا اتراكشن وبيصيروا يلزقوا على بعضهم. هودي اللي بيلزقوا على بعضهم بيعملوا شو بيقولوا سوليد وكربون وكذا. هو اللي هيك بنعمل بلانيتاري سوليد تيرستر اون جرو، يعني على السريع. agglomeration.
طيب في سؤال من مهدي شاكرون.
نعم.
مرحبا دكتورة.
أهلين.
بسبتمبر الشهر الماضي في ساينتست نشروا ورقة قالوا إنه they detected فوسفين بالأتموسفير تاع الفينوس.
صح.
وهلا في two theories. أول شيء لأنه الفوسفين هو مش naturally occurring molecule، ففي منهم قالوا إنه هيدا result لgeologic أو atmospheric process. شيء قال إنه في لايف. لنفترض إنه تاني hypothesis صح، هل هذا بيغير موقع فينوس شارت اللي فرجيتينا عليه؟ يعني بيصير من ضمن الهابيتابل زون او most likely to have an intelligent او لايف بشكل عام او لا؟
سؤالك كثير انترستينج، وميرسي كثير لانه نسيت احكي عنه لما فرجيت الهابيتابل زون. ثانك يو. مزبوط. ب 26 الشهر الماضي تلفنوا لي قالوا لي رح يجوا من فينوس وفي عالم وكذا. يا جماعة من 20 سنة حطوا على نيتشر إنه في ميثان on مارس. تعرفوا شو يعني الميثان؟ ميثان يعني when an animal fart we can detect this when we fart also. فكان الميثان يفكروا بس إنه it's بقايا الحياة، فقالوا we detected. فيكم تشوفوها بنيتشر من 20 سنة، كانت ايه من 20 سنة، بس انه انا كنت انجا اعرف اقرا. فكانت حطوا الكفر انه the quantity of methane we detected هو كأنه في من 2000 ل 3000 كاو on مارس. صاروا العالم يقولوا شفتوا هودي الوجوه تبع مارس. بعدين لقوا انه this is an effect, geological effect of methane. هلا زيت الشيء before shouting that it is life, you have to know, my dear astro lovers, إنه we know a lot of things in physics, in astrophysics, in astrobiology, in chemistry, in mathematics, but yet we don't know, we know nothing. يعني على طول ليش حلو العلم؟ لأنه we do theory, we do a scientific model, we do observations. إذا طابقوا مشكور next. إذا ما طابقوا ما منغير الobservation، ما منكسر فينوس. we change our scientific model, equations كذا. so in Venus شو صار؟ شغلة من اثنين مثل ما قلت لي حضرتك، أو يعني our models في اشياء بعد ما بنعرفها chemical. so هلا شو عم بيعملوا الساينتست اللي عم بيشتغلوا بفينوس؟ عم بيشوفوا يغيروا الايكويشن، الكيميكال ايكويشن. سو اذا بيخلقوا in the simulation من الهود الايكويشن شيء مثله، يعني it can be possible just purely chemistry and maybe 10% حياة. if not يعني maybe it is life. and if it is life يعني بنرجع انه our model of habitability has to be revised. مش يعني منشيل فينوس منحطه بالزون دابيتاب، يعني بدنا نرجع نفكر شو يعني حياة. لأنه الحياة مثل ما بنعرفها هلأ ولا ممكن تعيش in a Venus environment. so شفتوا شو حلو؟
اوكي، هلا بناخد سؤال من محمد حمية مرة تانية.
أهلا وسهلا.
سوري عفوا، ما عملت ريز بالغلط، ما تاخذوا.
اوكي. في أسئلة بتشات لكن أنا حقولهم. في أول سؤال من هادي شكر. How do we know a given planet in the habitable zone contains the necessary elements to be habitable?
بنعمل بالترانزيت in the method of transit لما تمروا we characterize the elements. أول شيء لازم تكون لحد هلا يعني لازم تكون صخرية that it has to be a rocky planet and it has to be في عندها elements ندرس لها بالسبكتروسكوبي. ندرس لها سبكتروسكوبي يعني أحلى طريقة أو أهين طريقة for the moment. في عدة ميثود بس أحلى طريقة لما تمروا إذا ما رأيت إذا هيدي الستار ما رأيت هيدي البلانت in front of it وعندها اتموسفير. so الاتموسفير بعمل لهم انا study للاتموسفير بالسبكتروسكوبي بالابزوربشن. it will absorb light of the star وبشوف شو في composition. اذا في مي اذا في شو عرفني انا CH4 اذا في HCN فيعني بتكون possible to have life.
Okay, second question من كريم أحمد بتشات. Yesterday, the dangerous effects of Starlink satellites was discussed and can cover and block a whole exoplanet. What can scientists and astro federations do to solve this problem? And is it possible to cancel the Starlink problem?
Thank you so much. كمان هذا كتير مهم وبوجعنا. Sadly enough, we cannot do anything. We wrote a very big email, and the answer of Elon Musk كان إنه kind of we are outdated. We have to observe from the space, and in the 10 coming years we will observe from Mars.
اوكي، في جواد علام عنده سؤال.
مرحبا. أول شيء بدي أسأل عن الدوافع اللي عم نراقب اللي عم نحاول نكتشف exoplanets عياد. أنا بعرف بعض الدوافع، بس عم بسأل عن المعرفة العامة. وكمان بدي أسأل إمكانية الوصول للإكزوبلانتس، لأنه مثلا كارل ساجن حكى بالكوزموس عن ستار شيبس ديزاينز، فيوتشر ديزاينز لستار شيبس وكذا. فهل هودي الديزاينز من الناحية الهندسية قادرين نوصل لهم بالمستقبل القريب؟ شو الوضع؟
كمان أسئلة بعد في شي سؤال؟ ولا هودي هودي هن سؤالين؟
هودي.
اوكي.
هلا بعرف كمان إمكانية الكوميونيكيشن، حتى إذا في intelligent life.
اوكي.
هل صار في تعديلات على دريكس إيكويشن بعد ما بلشنا بالديسكفري لإكزوبلانتس؟ لأنه كان في عدة فاكتورز حواليهم أسئلة، فممكن يكون تغير بهودي الفاكتورز من وقت ما كارل ساجن أول شيء حكى عنها وكذا.
أنا قلت لهم للمنظمين، قلت لهم بدي 6 ساعات بس إذا لحتى أعمل الكونفرنس، يعني والله العظيم وصدقوني يعني اختصرتها طيب ميرسي كتير. الأسئلة عن جد بشكر كل اللي حضروا الكونفرنس، وأسئلتكم عن جد كتير انتريسانت، وهيدا أنا قلبي بيكبر لما أشوف قد إيه هيك محمسين. ما كتير لازم نطول ناخد من وقت، بس إنه بجاوب على هيدا، ولما نخلص نثبتكم برجع نعمل حرام، لأنه بركي عندهم شيء بعدين. أوكي، بجاوب أنا هلا وبناخد الكونفرنس اللي بعدها، ورح ضل معكم إذا بدكم بجاوب بعدين على الأسئلة هيدا. شو قلت لكم يا محمود ويا جنى؟ طيب الدوافع ما بكذب عليكم وعلى كل الاسيستنت هون بالكونفرنس. من اول ما خلق الانسان وبلش يفهم وصار هيك، صارت البصيره عنده كتير واعيه، بخاف من الموت. ما حدا يقول لي لا طب، لا العلم، لا البيولوجي، ولا الدين، ولا شيء. هو الدافع الأول هو الخوف من الموت، بعدين الحشرية ليشوف إذا هو الأوحد أو لا. بس بعدين بتقلي التكنولوجي الكذا. هلأ أنا عم بحكي معكم شوي فيلوزفي. الدافع الأول
صرنا عم نتساءل على الانثروبوسنتريك موديل.
exactly. أول دافع ليش الإنسان صار يفكر إذا راح قلبه يركب قلب اصطناعي ما بده يموت؟ ليش عملوا أنت ما بدك تموت؟ ليش هلأ كلهم بيشدوا ما بدهم يموتوا؟ بتلاقيهم هيك ووجههم هيك ما بدهم. عرفت؟ هيدا أول دافع، الدافع الوحيد والأوحد، لأنه بالانكونسيون تبعهم إذا في حياة بيرتاحوا. anyway، هلا تاني شغلة، شو هي الإمكانية السفر على أي إكزوبلانت؟ هلا بقول لك، قلت لي بالفيوتشر القريب 0. بس أنا بقول مع الساينس impossible، المستحيل مش موجود. الإمكانية اللي معقول تصير يمكن تاخد وقت، بدها كتير تكنيكاليتي، يعني لازم نصير نقدر نعمل كريوجينيك سليبينج، وهذا مش حلم ولا ساينس فيكشن. لأنه لنسافر بسرعة الضوء it's impossible طول ما عندنا ماس ما فينا نسافر، ولحتى هلا نسافر من نستعمل التانلينج ونعمل سبيس تايم بندنج مع الجرافيتي مش هلا. سو بتصور بعد شي 300 سنة فينا بس نيو تكنيك. وإمكانية الكوميونيكيشن impossible for me صفر، لأنه تخيل أنت في فرق بس أنجأ 0.3% أو 3% مع الشمبانزي، ما بعرف قد ايه تحديدا، وما فيك تحكي معه. فتخيل أنت عم تحكي مع واحد جاي مطور أكتر منك بشي 7 مليون سنة أو مليون سنة، وفرق أنت والدي ان اي تبعه شي 10%. تجي أنت عم بتغني له أو عم تكتب له بالكمبيوتر تبعك، بصير يطلع فيك، يعني بصير انه مش عم بيفهم عليك، مثل انت عم تحكي انت والنمله مثلا، في شي مره جاوبتك النمله. So I think that communication with ET إذا موجودين it will be impossible. ودريك فورمولا A حصل عليها كتير تغيير، لأنه هلأ نحن دريك فورمولا it's not just to communicate or to مثل وطينا شوي الهوبس تبعنا. بس إذا بدكم بحط لكم إياها بعد شوي لما نسمع الكونفرنس وبنحكي عنها.
Okay. Thank you.
Yeah.
Okay, thank you so much, Dr. Cyrine, for the talk, for the answers. The questions كانوا كتير حلوين.
عن جد.
We're going to stop them now, as you said. وإذا في حدا بحب يسأل شيء after the second talk,
أنا هون.
we'll give some time. Okay.